Hello, welcome again to the week 8 of Advanced Concrete Technology course. Without further ado, let me move to the presentation. Is the screen visible to you all? Can you confirm by putting a message in the chat box? Is the screen available to all? Yes, okay. Thank you. Let's move to the week 8 session. So, the first question is: the paste equivalent to the void content provides the adequate workability to the system. So the question here is: the paste equivalent to the void content provides the adequate workability to the system, whether it's a true statement or a false statement. Okay. So moving on to the correct answer. So the correct answer is false. Why? Because we need the paste which is more than the void content of the system in order to provide adequate workability. Paste just equivalent to the void content is not sufficient. We need somewhat more than what is filling the void. So if we are just giving the paste equivalent to the void content, then the voids will be filled. That's all. It will not be contributing to the workability of the system. So in order to provide workability, we need the paste content which is more than the void content of the system. So the statement given here is false. Okay, moving on to the next question. Roller compacted concrete requires high workability. So, roller compacted concrete requires high workability. So, this is a type of concreting used in the pavements. So, here the statement is that it requires high workability. Okay. So, the correct statement is false. Thank you for replying in the chat box. So basically the roller compacted concrete does not require any workability and the requirement is zero slump. So it can be compacted using the roller. So we do not require higher workability for the roller compacted concrete. Okay, moving on to the next question. To check the concrete workability, mind you, it is concrete workability and not the mortar workability or the paste workability. So to check the concrete workability, it is wet sieved through the options are 30 micron sieve, 4.75 micron sieve, 75 micron sieve, and 50 micron sieve. So wet sieving is a process followed to check the concrete workability. So what is the sieve size through which the concrete is sieved to check the workability? I mean, as one of the step before checking the workability. Okay. So the correct answer is option B, that is 4.75 micron sieve. So the next question, it is also related to checking the concrete workability. So the question is, what is the apparatus which is used to check the concrete workability? That is, a concrete workability is checked using dash. The options are slump con, option B marsh con, option C penetrometer, And option D, Viket apparatus. Let me put it in the chat box again. Concrete workability is checked using slumpcon, marshcon, penetrometer, and Viket apparatus. So, which is the correct option?
Option A, madam.
Okay, thank you for replying. Let me wait for others as well. Okay, unfortunately, the correct answer is penetrometer. Slumpcon is used for the paste or the mortar workability. For looking into the concrete workability, we can go for penetrometer. So, moving on to the next one. In maturity testing of concrete, that means in order to understand how far the concrete is set or what is the age of setting of concrete. So, in maturity testing of concrete, dash of concrete is measured at regular intervals. So, what helps in getting the maturity level of concrete is the question. Okay. So, the options are workability, that is checking the concrete workability at regular intervals, or checking the slump retention at regular intervals, then temperature at regular intervals, and density at regular intervals. So, what is checked at regular intervals in order to test the maturity of the concrete? Okay,
Option A, madam. Workability.
okay. So, let me try to enlarge the window. Is it? I hope that's fine now. Yeah, thank you. So the options are workability, slump retention, temperature, and density. Okay, thank you guys for responding. So, what is measured in order to check the maturity of concrete is a question. So, at regular intervals, we need to measure something. It has to be somewhat an easy measurement again. So, generally, what is measured at regular intervals to test the maturity? Okay, so moving on to the correct answer. The correct answer is C, that is temperature. Okay, we measure generally the temperature. See, we can always measure the workability or slump retention or density, but it is not that easy. And when the concrete is kept on place, we cannot keep on checking the workability or the slump retention. So we generally go for checking the temperature of the concrete. Okay, moving on to the next question. It's based on rheology. So the yield stress and plastic viscosity are two important parameters in rheological behavior. The yield stress is a measure of 1 and plastic viscosity is a measure of 2. So what is 1 and 2 is the question. Option A states 1 is stress required to stop the flow, and 2 is the friction between the particles. Option B states 1 is stress required to overcome to start the flow, and second one is adhesion. Third option states 1 is the stress required to initiate the flow when the material is static, and 2 states resistance to flow. Now, option D states both A and B. Sorry, B is also there. Both A and B. Okay, thank you guys for responding. Let me wait for a few more seconds so that others can also respond. Okay, thank you. Okay, so without doubt, all are telling that the correct answer is C. That is, yield stress is the minimum stress required to initiate the flow when the material is already in a static state. And and the second one, that is plastic viscosity, it's a resistance to flow. So the correct answer is option C. So I think all of you might have thought the correct answer is C. So good for that. And shear stress, as you can see, this is just from the slides. So the shear stress is a minimum stress needed for the flow to initiate. And plastic viscosity, if the fluid remains in the laminar regime while flowing between two solid particles, its contribution to the shear resistance will be proportional to the overall strain gradient. So that is a plastic viscosity. So it indicates the resistance to flow. Moving on to the next question. Please name the rheological models from 1 to 4 from the figure. So here it is correctly given 1, 2, 3, and 4. You have to name them. So you can put it in the chat box as 1 is so and so, 2 is so and so. I'll give some time for that. It's very easy question is what I think because this is directly from the slides. There's nothing difficult or complex in this question. Just name the rheological models. There's a high chance you can confuse between 1 and 3. Um, yeah, so that is the only complexity here, is what I think. So, thank you, Balu. Anyone else? Okay, second is Bingham, 4 is Newtonian. I'll wait for one more minute. Okay, easy, Balu is right. Okay, I'll go with that. So, first one is shear thickening, second is Bingham, third is shear thickening, and four is Newtonian. Okay, let me wait for a minute. So, can someone give example for Newtonian fluid? Anyone? Okay, water, yes. Yeah. Water is a Newtonian fluid. What about shear thickening? Shear thickening. Oil. Okay. Okay, I guess no more answers are coming up for this question. Let's move to the answer. So yeah, so here from the figure it is evident that the first one is shear thinning, second one is Bingham, third one is shear thickening, and the fourth one is Newtonian. So the difference between Bingham and Newtonian is that there is no initial yield stress in the case of Newtonian, whereas that is present in the case of Bingham, and one which is slopes down or stoops down is shear thinning, and one which goes upwards is shear thickening. Okay, so moving on to the next question. Yes, this is a pretty long question, so I'll give enough time to read the question, understand. Okay, I think the full question has not come. Okay, sorry. Okay, so there are three fluids A, B, and C. Now, the fluid A, it starts flowing as soon as pure shear is applied. That means no initial resistance was there for the fluid A. And the fluid A doesn't show any hysteresis and follows a linear relation between the shear rate and the shear strength. It's just a linear relation. Now, considering fluid B, it mimics the stress to shear rate behavior of fluid A. It mimics it, but what happens is it possesses a material characteristics by which a minimum shear stress is required to initiate the flow. So, in the case of A, the initial shear stress was not required, but in the case of B, initial shear stress is required, but then the response is similar to that of A. Now, there is C, it mimics the behavior of fluid B during the loading phase, but changes to a lower yield strength during the unloading phase. This fluid C has the inert ability to rebuild the microstructure when kept constant without any shear action. So, what are the type of fluids? So, fluid A, it has a linear relation but without any initial shear stress. And option B, it also has a linear relation but it has an initial shear stress to overcome. Now comes option C, that is it follows the or mimics the behavior of B, but then when it is unloaded, then it comes to a point where the yield stress is much lesser and it can rebuild its own microstructure with and when kept constant without any shear action. Without shearing, then the microstructure can be rebuilt. So, what are the type of fluids is a question. Okay. Option A, rheopectic, pseudoplastic, and Bingham fluid. Option B, Newtonian, non Newtonian, and shear thinning. Option C, Newtonian, shear thinning, and thixotropic. Option D, Newtonian, Bingham fluid, and thixotropic. Okay, so Reddy has commented that it is option D. Okay, thank you for responding. Anyone else? Okay. Balu has commented that it is Newtonian, non-Newtonian, and shear thinning. Same goes with Harsha. I'll wait for just one more minute and then we can discuss the answer. Okay, Naveed has commented it is D. Anyone else? Okay. Okay, so let's move to the answer. The correct answer is D. So in first case, we all know that it is Newtonian because it follows a linear relationship and there is no initial shear stress. So if you see here, there is no initial shear stress or yield strength stress required. So it is a Newtonian fluid. Now in the case of B, it says that option B, the fluid B, it mimics the fluid A but with the initial shear stress. So it has to be Bingham. So non-Newtonian means it can be anything other than Newtonian. So Bingham clearly states that it mimics the performance of Newtonian, but with the initial shear stress, that is the yield stress. So option D only states that B is Bingham fluid. So generally we can go with that. But even then, just to confirm, what about C? C shows that in the hysteresis loop, when it increases or during the loading stage, it mimics B. But when it comes back, it goes to some yield stress which is lower than that of the initial yield stress. So it just continues the path. And also, one more additional thing is that it can rebuild the microstructure when it is kept constant without any shearing. So that is the exact definition of thixotropy. Okay, so the option D clearly matches with the descriptions given. So option D states A is Newtonian, B is Bingham fluid, and C is thixotropic. Okay, now moving on to the next question. Match the following. So you can just type 1, 2, or 1, 3, or 1, 1 like that. So these are devices with general characteristics used in the measuring the rheological parameters. So the devices are cylindrical rheometer, parallel plate rheometer, and vein rheometer or vein shear rheometer. So the corresponding options are the spacing is less than 1 millimeter between the walls, and one surface is stationary, and the last option is can be used for mortars. Okay. So thank you, Balu, for commenting. I mean, for the quick response. Let's wait for others as well, whether they have to comment something on this. Uh, what is AA? Because no options are given. So you are supposed to mention it as 1 1 or 1 2 or 1 3. Okay. Harsha, there is no ABC, but that's okay. Totally fine. But I understood that what you wanted to say was 1 1 2 2 and 3 3. Yes. Okay. So I guess it's safe to go for the answers right now because all of you have commented it correctly. So in the case of cylindrical rheometers, the spacing between the walls is very less. So we can generally go for paste, not for the mortar. So and It's correctly given there is spacing less than 1 millimeter between the walls. So that is corresponding to the cylindrical rheometer. Now, coming to the second one, that is the parallel plate rheometer. So if the rheometer is the parallel plate, then one surface is kept stationary and the other surface is rotated. So in that case, second and the second option matches very well. Now the third one is vane rheometer. In the case of vane rheometer, we can use it perfectly well for the mortar samples. So that's how the answer goes. Now let's move to the next question. I think all of you have answered it correctly. So now this is a true or false statement. The setting time of cement paste and cement concrete will be the same. So state true or false. The setting time of cement paste and concrete will be the same. I guess this is a very easy question for you. False. Okay, Harsha and Reddy. Anyone else planning to comment? Okay, Balu. Let me wait for 2, 3 more seconds. Yes, okay. Thank you. I'm happy to see new names in the chat box. It's nice. Please keep on responding. There's nothing wrong if you are opting for a wrong answer. No problem. Okay. So yeah, moving on to the correct answer. The correct answer is false. Paste and the concrete setting time will be differing. Concrete will also have the effect of aggregates from that different from that of the cement paste. So the setting time will be affected. That hence the setting time of cement paste and the cement concrete will not be the same. So the correct answer is false. Okay, moving on to the next question. The Herschel-Buckley model equation. So the equation is given. So it can be used to represent the shear thickening and shear thinning behavior of the concrete. That depends upon the value of the B, which is a material parameter. A and B are material parameters. So my question is, what does B less than 1 and B greater than 1 signify? So B less than 1, does it signify shear thickening or shear thinning? Also, B greater than 1 makes it shear thickening or shear thinning. So Herschel-Buckley model is one of the models which we are um, using to represent the concrete behavior, that is the shear thickening and the shear thinning behavior. So basically the shear thickening, whether it is a shear thickening behavior or thinning behavior, it depends upon the value of B. So if B is less than 1, what is it? Whether it is shear thickening or shear thinning, and if it is B greater than 1, then whether it is shear thickening or shear thinning. Okay, Naveed, thank you. So B greater than 1 has to be shear thinning according to you. Okay. Okay. Balu says the opposite. B less than 1 is shear thinning. A is shear thinning and B is shear thickening. Okay. Thank you. Okay. what is B less than 1, Pavan? Is move. No, that's it. So what is B less than 1? What do you wanted to convey? So Harsha says B greater than 1 is shear thinning. Okay. Is there anyone else planning to comment? I think not. So moving on to the correct answer. So B less than 1 indicates shear thinning and B greater than 1 indicates shear thickening. I know this must be confusing, but some easy ways to remember might be less than 1 means it is somewhat decreasing, or in your mental picture you can have something like very less or little like that. So that can be associated with shear thinning to the word thinning. And be greater than 1 means it is more or it is thick. The other one was thin. So something like that correlation, if you can mentally make, that might help you out. So B less than 1 indicates shear thinning. So here it is n. So the value is, the value is less than 1, then it is shear thinning, and if the value is greater than 1, then it is shear thickening. Okay, so keep that in mind. Less than 1 is lesser, so it is thinning. Greater than 1 means it is bigger or thicker, so it is shear thickening. So something like that. Okay, moving on to the next question. The diameter of the pipe used for concrete pumping should be at least 3 times the maximum size of the aggregate. So state true or false is a question. Okay. Thank you for the very quick response, Balu, Harsha, VCS Reddy, and Naveed. So the diameter of the pipe used for concrete pumping. So the dia should be at least 3 times the maximum size of the aggregate used in that concrete. Okay. Thank you, Nikhilesh. There is option A true. Any other comments from your end? Anyone? Okay. Thanks, Pavan. So the correct answer is true. So this is a screenshot of the slide. So it states that the pipe diameter should be at least 3 times the maximum aggregate size. So dia has to be 3 into the maximum aggregate size. At least. Could be more, but at least it has to be like that. That is for facilitating effective pumping, otherwise there will be clogging and there will not be effective pumping happening. So let's move to the next question. I think this is the last question for today. So the slump flow test is used to measure the workability of self-compacting concrete. Now, slump flow test measures overall spread and time to spread 500 mm. Please identify the indirect findings from the slump flow test results. So again, read this very carefully. Yeah, read this very carefully. There is overall spread, whether that indicates the yield stress or viscosity. Also, time to spread 500 mm, whether that indicates yield stress or the viscosity. So that is a question. So in the case of self-compacting concrete, when we do slump flow test, it measures the overall spread. Oh, um, I didn't understand that when all giving B answer. Okay, that is a collective response. So I'm a bit confused here. Can someone explain what is B? So the slump flow measures both. Overall spread also it measures, and also we can measure time to spread, time taken to spread 500 mm. So from overall spread, what does that indicate? Does that indicate yield stress or viscosity? And also, what does the time taken to spread 500 mm indicate? Does that indicate yield stress or the viscosity? Does that indicate viscosity or the yield stress? Okay, Naveed commented that overall spread indicates viscosity. Okay. I seriously didn't understand what that B meant. Everyone was commenting B, B, B. Okay. Okay, time to spread indicates yield stress. Okay. I'll wait for one more minute. Are you guys there or gone? Please read that question carefully. It's just a self-compacting concrete and we can do slump flow test. It has two parameters to be measured, overall spread and also the time it took to reach the 500 mm spread. So what does each indicate is a question. So the overall spread indicates whether it indicates viscosity or the yield stress, and the time to spread 500 mm, whether that indicates the viscosity or the yield stress. Any comments? No? Yes? Okay, Shwetank. Overall spread is yield and time to spread also yield, or time to spread is viscosity. Okay, so time to spread is viscosity. Okay, thank you, Shwetank. Okay, so yield stress and viscosity. So meaning overall spread indicates yield stress and time is viscosity. Okay, Harshashi's overall spread is viscosity. This is interesting. I'm getting mixed responses. Anyone else wants to pitch in? Okay, so I guess that's it, and it's a bit confusing for some of you. No worries. So the correct answer is that the overall spread indicates yield stress, and the time to spread 500 mm it indicates viscosity. So it's very easy if you just think about it. Maybe if there is water and if there is honey, honey is much viscous than water, and suppose we don't know that what is more viscous, then what can we do? We can take equal amount of honey and water and make it and flow through a surface at the same time from the same point. So to reach a particular distance, how much time does it take? If it is highly viscous, it will take more time. If it is less viscous, it will take very less time. So the time factor is it measuring the time factor is easier to know about the viscosity. So time to spread 500 because we are not getting any yield stress understanding from measuring the time. So the time to spread 500 mm it indicates the viscosity. And the next one is overall spread. So the overall spread can be used to understand the yield stress. Okay, so that's it. Thank you. Let me stop the sharing. Yeah, yes. So that's all for this week. So meet you all in the next week with the week 9 portions. I hope you all will watch the videos and attempt the assignments before coming to the live session. And it will be much happier if you all could respond in the chat box. I know many of you do, and thank you for that. But those who are reluctant to respond, please don't do that. Please respond, then only we can keep it much interactive as possible. Okay.